Welcome. In this video, let us understand the concept of degrees of freedom. Degrees of freedom, also written as DF, is a basic concept in statistics, and in this video let us understand it. Let us start with an example. Without restriction, this example refers to without restriction. Okay. Suppose I give you 3 boxes and ask you to, here n is equal to 3, there are 3 boxes, and I ask you to fill these boxes with any value. So you are free to fill any value in this box, in this box, in this box. So here degrees of freedom, the freedom you have is 3, or it is same as n. Now let us understand the same example with restriction. Suppose I give you same 3 boxes, but this time I ask you the sum should be 30. So there is one restriction here. So here degrees of freedom, suppose you fill the first box, you are free to fill with any value here. Suppose if I fill with 10, and then one more freedom I have, I can fill with, let's say I fill it with 5. So 10 plus 5, 15. So total sum should be 30. So I have to fill this value with 15 only. So here degrees of freedom is 2 here, because this value here I don't have any freedom, because for this restriction 30 sum I have to fill this with 15. So here degrees of freedom is n minus 1. Here it is 3 minus 1. That is, there are 2 degrees of freedom here. Now let us understand the concept of degrees of freedom in case of contingency tables. Let us start our example with 2 by 2 contingency table. Suppose you have been given with 2 by 2 contingency table, and row totals should be this much and column totals should be this much. Now let us start filling these values with filling these cells with values. The first cell, let's say I fill this with 5. Now this I have to fill with 10 only. There is no other option. Here also again I have to fill this with 5 only to make this as sum as 10. And this also, if I fill this with 10, again 20. So only degrees of freedom available, we are free to fill only one cell here. So that means in case of contingency table, row minus 1 multiplied by column minus 1. So here 2 minus 1 into 2 minus 1, 2 columns, 2 rows. So this is 1. So degrees of freedom in this case is 1. Now let us take another example of 2 by 3 contingency table. Row totals and column totals have been given. Now we have to fill. Suppose let us fill this with 5. Now this value I have to fill this with 5, right? So there is no degrees of freedom. This I can fill. Let's say I fill this with 4. Now 9, 6 I have to fill with this 6. So there is no degrees of freedom. This value I have to fill it with 6. This value I have to fill it with 4. So there is no degrees of freedom here. So only degrees of freedom is 2 here in this case. Again the same formula, r minus 1 into c minus 1. So it is row, there are 2 rows, there are 3 columns. So it is 1 into 2. So 2 degrees of freedom in the case of 2 by 3 contingency table. Now let us take the example of 3 by 3 contingency table. Row totals, column totals have been given. Suppose I fill this with cell with 5, and I am free to fill this value, this cell also. Let us say I fill this with 4, 5, 4, 9. So this I have to fill this with 1. There is no degrees of freedom here. I am free to fill these cells also. These cells I can fill, let's say I am filling with 3. This I have to fill with 2. This I am again free to fill, right? this, let's say I fill with 3, 2. This again I have to fill with 5. This I have to fill with the 4. This 14. So degrees of freedom in this case is 4 here, which is same as r minus 1 multiplied by column minus 1. In this case 3 minus 1 into 3 minus 1, that is 2 into 2, that is 4. So 4 degrees of freedom in case of 3 by 3 contingency table. Let us understand one more concept, Bessel's correction, in this video. The formula for estimating the sample variance S square is summation of xi minus x bar square divided by n minus 1. Here you can see denominator, instead of n, here it is n minus 1. What could be the reason? Because for estimating the sample variance, we also need the sample mean, right? So for estimating sample means, we have already used the 1 degrees of freedom. So we are left with n minus 1. So hence the denominator for sample variance is n minus 1, which is also called as Bessel's correction. So in summary, for the entire video, the degrees of freedom is sample size n minus number of parameters to be estimated. Number of parameters to be estimated. So this is in summary, degrees of freedom is n minus number of parameters to be estimated. So this is all about degrees of freedom. You are welcome to leave your comments in the comment section. If you have learnt anything new, if you want to learn more concepts, that also you can mention. See you in the next video.